I had purchased some used Tascam heads from the usual suspects, and they came in looking pretty good. I was a little pushed for time when I saw these on my phone and kind of jumped the gun a little bit before I looked at them carefully. The seller did provide sufficient pictures to know, what was going on with these, but I didn't really pay close enough attention to them. But that's okay. I like to have these heads around. They're not getting any more plentiful, and can see that they've had an attempt made at relapping with the guides glued on there with some epoxy. This is a brand new factory head, same part number. Kind of see how they come. And I have these here, but they're also dedicated to decks, and so I'm always keeping an eye out for any possible replacements or future stuff. And also for my own. I have several decks that use these heads, and they are a lot of times running constantly, doing archiving for other people, and so the heads wear out, and it's good to have backups. So let's get a little closer look at them. Okay, you can clearly see that they've been relapped. They've also been banging around in a drawer quite a bit. Don't usually see this kind of damage. You can see that they've also been the victim of a guide bender, which is interesting because they've also been epoxied back on. So what's the story here? Why were the guides bent and then epoxied on? Well, here's one of the problems with bending guides, of course. I don't have to say much about that. It's purely visible. I can say if you look at that, the groove marks, the wear marks in it, that they have reinstalled the guides backwards 180 degrees of where they should be, because those wear marks are going the wrong path of where the tape cut into them. So now looking at the bend marks, yeah, it's pretty obvious that they pulled these guides back or bent them back, and they came off. Probably what happened here, just kind of trying to deconstruct and understand why they're bent and epoxied, bonded back, and they're reversed. You can see by those spot welds that this is the side that was actually against the housing, not the spot weld side. So what's the story here? What I think took place on these, and there are two of them, identical. I think the guides were bent out of the way for the lapping to take place. Lapping took place. They bent the guides back, and in doing so, they probably broke the spot welds. There's other reasons I think this happened, and I'll show them here in a second. I can see tool marks that are clearly following the lapping. The needle nose pliers, whatever, were used to try to bend those guides back. I'm not a guide bender. I don't like doing this for multiple reasons, and this video will demonstrate, I think, a lot of my reasons why I don't like that. Anyway, there's what that one looks like. The actual lapping job isn't that bad. They're a little dirty right now, but when I look at them more closely, the lapping is pretty decent. Okay, so there's what these look like, the condition I received them. Let's take a look at a brand new set from the same viewpoint. Now, these look dirty. They're not. I have some anti-corrosive spray on them. So that's what you're seeing there. So there's the brand new guides. You can see they're straight. There's no kink marks. There's also no sign of flat marks on the heads. They have a nice radius. The profile is correct without any sort of flat. Looking at the specular highlights, there's no flat spots in the radius. Now what I'm paying attention to. So that's the difference. This is also maybe kind of a good example of why I like to just polish the insides of those guides. They are stampings. They're stainless, and they're a little rough. They're a little coarse on the inside, and I like to take a piece of 3000 grit and just polish those. Make it a little easier on the edges of the tape when it's engaging and disengaging. I like to break the edges and polish without opening up. 3000 grit won't open up very much, but it will polish the sharp edges. Okay, here's the second head that was purchased. Pretty much exactly the same way. Trying to kind of show the little bit of a flat spot. I know it's hard to pick up. This is a binocular microscope, and I can see quite a bit more. But see, the actual what got lapped was not that bad. It's the guides that aren't so well, and I'm not sure about the radius. I'm not sure about the profile. I'll have to check that separately. But just looking there at the lines, at the specular highlights, you can see that it's not uniform. So just as an example, this is a brand new, obviously a half-track head, Nortronics, for one of my other real decks. I don't remember which one, maybe the Otaris. You can kind of see how there's no flatness there. It's a true radius, a nice profile. It's uniform all the way from one end to the other. Where the tape engages, there's flatness on the end there, but the tape doesn't engage there. That's fine on the, what I should say, the outside parameters. You kind of see two lines there where it turns flat, and that's fine. That's how they should be. But in between those two witness lines, witness marks, there's no flat spots. It's a uniform radius. Here's another example of a worn out head, 24 track. You can actually kind of see the gap without magnification. This is actually visible to the naked eye. These are wear grooves. Very good idea to keep the edges of the tape from curling up while it's wearing. And when that wears down to the width of that wear groove, they're done. It's time to change them. I don't think this is the one. Maybe this is. I have another one that really clearly shows the gap opening up on one side. I think it's this one here. This one wasn't aligned correctly, and so the gap on one end is much greater than it is on the other. Yeah, you can kind of see how it's narrowing down here. And you can also see the amount that it was out of parallel with the tape. I know not the greatest magnification here. This is just my little low power microscope on the bench. This isn't the one I'll use for showing the gaps. Anyway, there's what it looks like. The other thing I noticed on these, which is not unusual, I actually see this quite a bit, is the two heads are not always in the same plane. And I noticed that it was obvious one of these was worse than the other. And what I mean by that is they're not both at the same height. And there's tolerance on this, and it's okay, but I think it's also better if they can be at the same height. And I think it's obviously this one here, that there's quite a bit of variance between the height of the two heads. So this is the worst of the two. This is the one I'm going to deal with on this video. The other big problem with bending guides, obviously, is not breaking them. But when they're bent back, they don't necessarily go back in the same position they started from. Bending sheet metal is, you know, it's not a precise thing when you're doing it with a pair of pliers or, you know, needle nose pliers, whatever. And so maintaining the correct gap is another issue. What I have here is a 150 thousandths gauge block, which is the minimum width for a tape guide according to NAB standards. And I want to measure these. Maybe I'll show it here. Maybe I can print out the spec, but the spec is 151 thousandths plus or minus 1. Now this is a brand new head, and you can see that 150 goes in there with a tiny bit of wiggle, telling me that it's slightly larger, which is correct. Here's another brand new head, a different batch. Again, exactly the same way, tiny bit of wiggle. This is one of the heads, and the gauge can't go in there. This is the other head with the bent guides, and the gauge does go in there. So there's a 50% chance on these two of hitting it, you know, right. Now that's out of spec. So those guides were bent out to be lapped, for the heads to be lapped, and then they were bent back, and other things happened as well. But that guide is no longer at the minimum spec for a tape guide, and that is a problem with bending guides. Here's the NAB. Like I said, 151 thousandths plus or minus 1. So from 150 to 152 is the standard on those. Again, 150 gauge block won't engage in there. So that's the head I'm going to work on. That's the most problematic one. These two small grub screws here are responsible for setting the record head tilt and ultimately the height. And they should be factory set. However, I've seen them actually out, and I don't know if it was, you know, a factory defect or if they worked their way loose. But they are inboard and not serviceable without removing the head, of course. So I don't expect this guide to be very well attached, and it's not. More than likely was bonded with 5-minute epoxy. It kind of looks like that, kind of has that feel about it. 5-minute epoxy is really not usable for many things beyond just I think the 5-minute isn't the set time, that's the useful life of it. Anyway, you can't just bond metal to metal without any preparation like this. It needs to be prepared and the correct bonding agent used. Now there's the 4 spot welds from the factory. And I can see that it was bonded to that used head backwards. Very obvious. Now let's see how well this epoxy adhered to the base metal. Yeah, about how you'd expect. I'll go into this a little bit more at the end, but it won't, yeah, it doesn't stick. It just doesn't. It has to be prepared. Now, let's disassemble this. Okay, on the record head, this back screw here is where the spring is, and that's what allows the other screw on the other side to set the azimuth on the record side. These are separately adjusted. That one actually doesn't look all that bad. The screws are tight. Let's clean the solder off of here. I'm going to plug this solder wick here. I've used a bunch of different ones lately because I ran out of my favorite one, which is this brand. And I have to say, this is the best solder wick I've ever used. And it's maybe the most expensive too, but it's worth every penny of it. I want to clean these up so I can give them a quick inductance measure and make sure I'm not just wasting my time here, that the heads are actually okay to proceed with. And there were a lot of solder bridges and things in here, so that's fine. I would have done this anyway. I would have cleaned these up anyway. First, I'm just going to blot the flux off and then just wipe them off with IPA. Okay, I think I've got them. I think I've got the bridges gone. And I measure them, but my film ran out of gas. So they did measure okay. I think I had, I can't remember, 200 millihenries and 20 something, 23. Anyway, they measured left to right channels were similar. And so I decided to proceed with the lapping. Okay, one more look here now that they're apart a little bit. Just kind of trying to show how lapping without removing the guides, and in the case of the repro head here, removing the shield, is really hard to get a good result. You can see the flat spots there kind of all the way through, and you can also see the lack of uniformity. Again, looking at the specular highlights, looking at the reflections, there's just a lack of uniformity there that You know, will it work? Yeah, it probably will. Is it in the tape path? I don't know. It might be out of the tape path, but I'm not willing to take the risk that it's in the tape path. So to me, the correct way to do it is to remove everything, get back to base metal, and try to maintain or re-arc the correct radius, the correct profile on the head. It's really very visible, like this. And you can also see it's actually not flat. For whatever reason, it wasn't lapped flat. And the thing that I can see that may not be so visible in that video, I can see witness marks where the wear took place, and they didn't quite get the witness marks all the way out. And that's fine, whatever. But the other part that bothers me is these scratches that are going perpendicular to the path of tape travel, and not even really perpendicular, some odd angle, 5 or 10 degrees. What I think this is, I think this was post-lapping tool marks from when they bent the guides back. I think this is a scratch that was that happened when the guides were bent back with the needle nose pliers or whatever, and the pliers were drawn back or removed. So again, is it in the tape path? I don't know, but it's not acceptable to me. And there's right there, it's perfectly obvious that that was a scratch mark because it didn't scratch the potting compound. Or it did, but it's not visible. It did the metal worse. It's a very soft metal. So I don't like this. There's a lot about this lapping job that I don't like. Now let's get a little closer here. Looking at the gaps. Again, seeing if I can detect anything that's been opened up or would cause me to just not even waste my time on this. These don't look bad. By the time I'm done with this, hopefully I'll have my lamp house rebuilt for my other microscope, which will give much, much clearer results than what I'm showing here. But I can still see what I need to see with this one. And the point is, I think the gap's good. I think I'm okay to go ahead and spend the time relapping these and trying to get them back to a good condition. Yeah, straighten that up so I can reverse the gap a little bit easier. Yeah, I don't see any indication here that there's a problem. Got the guide straightened out, and I want to see now if I can possibly determine the original position of the guide using the original spot welds. And, you know, a lot of times it's possible. A lot of times it will just fit right in like a jigsaw puzzle. In this case, I'm not feeling it. It's not there. So we'll take those down, maybe give it one more try. And because I'm not really hopeful that I'll be able to determine that, I just want to make sure that I've got a clean face to reference off of if I have to come up with a different way. So try it one last time. Yeah, and no, it's not going to happen for me. That's okay. I have other means. Okay, not hugely important here, but I just want to try to get a feel for the depth of the guides. In other words, how far down from that radius they start. Let's get this thing over on the optical comparator. What I want to determine here is the distance from the center of the guard band to the reference edge of the head. So I can put that guide back centered. And they give us, NAB gives us 10,000ths on this, which is, you know, a mile and a yard in my world, but I still want to get it as close as I can. And what I've done is I've used a square block to line up the edge of the tape head to the edge of that 1, 2, 3 block. And so as long as I'm fixed on that point, I'm in good shape. I actually made a mistake here and made my reference between the two channels, between the left and right channels. And so eventually I caught that and I went back, and these are the correct numbers on this head. And so what I did was model up a fixture for holding the head and the guide in place with the correct distance on the face that I measured against, and then to the center of the guide block, or to the center of the guide. And then this block will position the guide on the head when the head is flush with the side of the reference face. So that's how I did this. So now let's get on to the lapping. So what I have here is a 3/4 inch thick piece of float glass. And I'm just cleaning it and scraping with a razor blade, trying to get any aspersions. Thank you, Robin Renzetti, for that term. Anyway, trying to get anything off of there that might interfere with the flatness of the plate. And I'll clean this off a few times. Let me see if I can maybe get the exposure a little more reasonable on this. And the focus, try to focus in so that I can show my lapping procedure. That's a little bit better. I like that. Now this paper towel is going to shed some fibers, and I'll eliminate those here in just a second. But first I want to mix up some honing fluid or lapping fluid. I'm using distilled water, a drop or 2 drops of Dawn soap, and a splash of IPA. And I find this actually works well, very well. Now the lapping film I'm using is PSA. It has a self-adhesive back, but I'm not prepared to commit to sticking this stuff down on a surface because I use this for other things as well. So what I'll do is use a little bit of spray adhesive. That is the non-permanent stuff, repositionable they call it. And then I'll be able to remove the lapping film as it's used and reuse it again. Just don't want to have any debris underneath the paper. That can really cause a lot of problems with lapping. I lap things almost every day in the shop here, and so I have multiple different ways of getting it done. Now this is just some plastic protective film that comes on sheet goods, polycarbonate, acrylic, things like that. And I save these when I fabricate because they act like a lint roller for your suit or dress. And they're really good at just pulling off the last little bit of debris that's on a clean surface. So what I'll do is just use this Loctite spray adhesive, which is repositionable. And that's how I'll temporarily adhere the lapping film to the glass plate. Well, that should be about as clean and lint-free as I can get it. Just give it a light spray. Try to keep it out of the lens, camera lens. Let it tack up for a minute. Okay, it's pretty good. Yeah, zoom in a little bit and get focused. And we'll give it a spray off with an air hose and spray the paper off also. The paper meaning lapping film. And then it's very simple to feel if there's anything underneath there stuck between them. I got a pretty clean job on this. The thing about lapping is that it needs to be done with a clean surface every pass. And one of the ways to do that is to flood the lapping material, in this case the film, with the fluid, something to flush it off with. This can be done under a sink. It works really well, or outdoors with a garden hose or something like that. In my case, it's kind of hard to do that and film it at the same time. And of course, right now it's about 23 degrees outside, so I won't be doing that. But this will do the same thing by using a lapping fluid, simple, and then cleaning the paper off between each series of laps, and then also not going over the same spot twice, just using fresh abrasive on every pass. As I progress through the higher grits, it's important to not go over the same spot, because the material that comes off will actually scratch the finer marks that were just taken out by the abrasive. So that's the purpose of the fluid, is to flush out those particles and not allow them to re-scratch the finer scratch marks that were just made with the abrasive. So that's the purpose of constantly flushing and constantly cleaning the abrasive, is to keep all those particles that were removed from the work from coming back in and scratching the workpiece. So this is how I do it. I am, of course you can't see it, but I'm concentrating more force on the fore and aft than I am in the middle, because the middle is been flattened a little bit by the prior lapping, and so I want to build that radius back up. The point, maybe we'll call it, I want to repoint that so that I've got the correct head wrap. The correct tape wrap on the head. Like I said, I just traverse it, clean it, traverse it, clean it, and go on like this for a little while. I'm starting out, I should have said, I'm starting out here with about a 4500 grit, according to the paper that came with the material. This is the kind of the standard aluminum oxide, hobby or craft paper that is sold on all the different sites. I usually stick with 3M stuff, but this is something I just wanted to try and see how it does, see how it holds up. I think I'll definitely go back to the 3M after using this, or Norton, either one is fine with me. Really is not necessary on these. These are pretty soft metal. It's not necessary to start out with much coarser than 4500, 3000 grit, whatever the micron equivalent is of that. If I do start out coarser, I'm forever trying to eliminate those scratch marks. So a few more passes with a finer film is, to me, better than having to spend so much time removing all the scratch marks. I think this one's about an 8,000 or 9,000 equivalent. Again, kind of concentrating on the, fore and aft side and letting the center be very soft. I don't know. That's the best way I can describe it. I'm trying to take more material off the heel and the toe to compensate for what was previously a flattened radius. And this paper is so fine and everything's so flat here that I can really feel, as I go through this, I can feel where those flat spots that were created previously are. And so I just work them out. It's all done by feel. Again, clean those particles out. At this point, I pretty much feel like I've gotten the radius back. And it's looking like I've done that. I don't see any anomalies. I don't see any flat reflections. It's looking pretty good at this point. Doing both the record and the repro head, of course. And my stickum's starting to fail, so it's time to redo that. I can see the speculars are looking correct now. Okay, let's swap this out. Give it another spray, clean it. So at this point, it's telling me light green is 1 micron, and the yellow is 12 micron. So I've got the yellow and the light green here, and my color acuity is good. I can tell the difference. But to me, this light green feels coarser than the yellow. And like I said, the words 3M or Norton on anywhere on this paper, and so I don't trust it. So I'm just going to avoid that 1 micron and move right up into the white, which is clearly finer than either one, and I'll just make a few more passes. And from this point on, if it doesn't say 3M or Norton on the box, I won't buy it anymore. Let's give it another splash. And continue on. And this is the procedure of lapping. kind of speed through this. Doesn't take so long. Really starting to look like a mirror now at this point. So this is 0.3 micron. I'm guessing it's somewhere over 40 or 50,000 grit. Okay, let's take over the microscope now. I've finally got my lamp house rebuilt, and so now I can capture a much finer image than I could before. So this is the freshly lapped repro head. And you can still see a little bit of the former coarse scratch marks from the previous lap job, but they're not bad. These are okay. I can live with this. Rather than taking more material off the head, I can live with tiny, half a dozen tiny scratches in there at a very fine level. Yeah, getting a little closer. The gap looks good. I don't see any cause for concern. Actually looks very good. And on this head, because there aren't guides to interfere with the objective, I can even get a little bit closer on this one. There. Again, this is the repro head, post-lapping. Really, mirror finish. No anomalies. So I have good confidence that this head will perform well. Yeah, this is the maximum magnification I can currently go to on this device. Okay, let's go see if we can find the gap on the record head. Of course, this will be the wider gap. Okay, so far so good. Okay, that looks really good. Yeah, nothing there that causes me concern. Okay. I'm happy with that. Just get a little bit broader view. Okay, let's go take a look at the other used head I bought that has not been, that I haven't lapped. And here's what that looks like in comparison. And you'll see a little surface corrosion here. That's why I always coat my heads with anti-corrosive for storage. This little bit here basically will come off the first few minutes of tape passing over it. But still, it's nice to not have it there to begin with. So this is the lapping job that was done before. And you know, it's not terrible, but it's not up to the standard of the other one. Let's see. Here's the playback repro head. Yeah, not really very impressive here. A lot of pitting. There's some of them are kind of deep. Some, you know, right in the gap. Not the best. Try to get closer on this, but I think the tape guide is going to interfere with the microscope objective. Okay, so here I have one of the newly purchased heads. Obviously the record side. And again, just, you know, the surface corrosion from lack of use. But this is the finish on a brand new Tascam head directly from TIAC. This is also the reason I always polish brand new heads before I install them. And here is the repro side. Again, brand new head. This is just flash corrosion. This would come right off. But the actual surface finish is not as high as what I've just done with the relapping. The scratch marks here are coarser than what I'm doing with mine. So here's, in comparison, the relapped head, one I just finished. You can see there's a higher polish, higher finish on the head. over here and take a look at the record side. Again, in comparison, higher finish, higher quality finish. Finer, what would you call it? Finer RA. Now this one doesn't have the restriction of the guide, so I can get a little bit closer on this one. So this is how it appears at double the magnification of the new factory head. Now let's go give it one more comparison to the factory head, to the new factory head. It would be half this magnification. Okay, so this is the new factory record head. It's got some cross grain scratches there. Probably lapped it in an X-shaped pattern, which is customary. Okay, so let's go look at the profiles. Here is the factory new repro head. And here's the relapped head. So very similar, certainly within 5/1000ths. Here's the factory new record head and the relapped record head. So I was able to maintain or come very, very close to the factory profile, which is what I was trying to do. Now on to bonding the guide and the shield back onto the repro head. The accepted standard for bonding ferrous metals to each other, or even brass or copper, for example, is bead blasting. There are other acceptable methods, but bead blasting is the preferred one. And then the other part of this is bonding it quickly after the bead blast. That's the reason the guide fell off so easily from the 5-minute epoxy, because that is not an acceptable way to bond these two materials. So this is Just removing. I masked it off so I wouldn't hurt or get bead blast anywhere I didn't want it to go. Just peeling off this polyurethane tape. This does not apply to aluminum, however you want to call it. That requires a separate chemical process, an anodizing adherent coating. I'm talking about steel and stainless steel like the guide is here. So this is bead blasted and then not touched, or touched very little, if whatever can be helped. This is a very low pressure bead blast. Thin materials like this will just collapse in a high pressure bead blast. So this is low pressure and very little work done. I'm just trying to keep these surfaces clean. There's my little positioning fixture. And I'll show you how this works. And there's the bead blasted surface. And I need to get a little bit of release agent on this positioning fixture before I do this, or else I'll end up with a much bigger head than what I want. Okay, so that's my reference surface. And as long as that is fixed there, and this also is the height stop for the guide. That's actually the reason I had to print several models. That was kind of a hit or miss. The models worked out fine, but I had to get the position, the height position. It's not totally critical. It's not a big deal, but I was just trying to match the factory head since I had one here to measure. Let's do this like this so the camera can capture it. Yeah, here's my release agent. Now, let's get it positioned, get it focused. Okay, I think you've got a good view of it here. I just need to make sure that the reference face of the head is in close contact with the reference face of the fixture. That's pretty good. You can see what a tight fit that is on the guide. Again, they give us 10,000ths tolerance on this, and I'm well within probably 2. Okay, very important to use the correct adhesive. I call 5-minute epoxy 5 minutes because that's how long the bond is good for. It looks like a lot for this little tiny job, and it is, but it's very difficult to mix small amounts of epoxy and get a 50-50 mix, and so it's always kind of customary to mix too much so that you get the correct amounts. Doesn't take very much. And try to keep it clean and neat as much as possible. Yeah, it's kind of an idiot-proof fixture. If it's in there and everything's tied up against everything else, it's in the correct position. I'm going to try to use a little piece of clear polycarbonate to kind of clamp that down. It's not really working the way I want it to. This clamp is a little bit small for this application, so when I move on to a different clamp, pull it up against the stop, and then push it up against the other stop, and I should be in good shape. Okay, I think that's good. I'll let that set up overnight. I think around 2 hours is the bond time on this particular adhesive, but the longer the better. And here it is the next morning. I cleaned it up a little bit, polished it out. Test it out on our fixture, make sure everything lines up the way it should, and it didn't move around during the curing process. Yeah. Turn it the right way, just like that. And that up appears to be just right. So now we'll just do the same procedure on the shield, put them back together, and we're on our way. So thank you for watching this very long video. I hope you enjoyed it, and I'll see you on the next one.